on a sleepy Memorial Day morning. And the office was quiet. I was fatigued. I just worked 2 long shifts over the weekend. I was keeping myself barely awake with the low hum of the space heater under the desk. And outside of the office, things were beginning to change quickly. And the morning runs of our forecast models were starting to pick up on the threat that lay before us. With each piece of data that we looked at, we grew our level of alarm from cautious to concerned to troubled. And as it turned out, there was good reason for those fears. When my shift ended at 3 p.m. with instructions to return at 8, I went home to get some rest. And when I woke up after a few hours before I went into the office, I did something that I have not done in years. I went to Taco Bell. True story, I never told anyone that. I didn't say it was a good idea. But before we can get into the event, before we can get into the largest tornado outbreak in the history of our office in Wilmington, before we can get into the 3rd largest tornado outbreak in the history of the state of Ohio, we have to go back to that morning and how we were thinking when I walked in 7 a.m. and looking at the weather setup with low pressure over Iowa and a warm front extending across Indiana and Ohio, the expectation that thunderstorms were going to develop over Illinois and into Indiana and then eventually drift southeast into the state of Ohio and into our forecast area in Wilmington. And the expectation was that the biggest threat for tornadoes and the most significant weather was going to be over Illinois and Indiana. In fact, our thinking at Wilmington was that this was going to be primarily a threat for damaging winds, with maybe some threat for large hail and tornadoes as well, kind of the type of severe weather event we're more used to getting. To give you an idea of why we were a little bit uncertain that morning, why there were some questions about how things were going to lay out, we'll look at an ensemble model run from the HRRR, the HER, and just to look at some of the different solutions that were out there that morning. So are we going to get an MCS, a squall line, something cold pool driven with a threat of damaging winds, or is it going to be more discrete, possibility of supercells? It was hard to tell at this point. What about timing? Are they going to move into the area, say, 7, 8, 9 p.m., or is it going to be later, more towards midnight or whatever? There was a lot of questions that we still had at this point, so we needed to dig into the mesoscale analysis and dig in a little closer to what kind of environment these storms are going to be developing in. And so at one point, probably 11:30 or so, I pulled up a sounding from the 3-kilometer NAM, a model sounding that gave me a significant amount of concern because there was sufficient instability for thunderstorm and even severe thunderstorm development. But we were going to be on the edge of that instability. But there's just a little bit of a cap. Sometimes on the gradient of the instability is where the most significant severe weather can occur. But even more concerning was the wind fields that we saw with a significant amount of low-level turning, speed shear, directional shear, especially in the lowest 1 kilometer of the atmosphere, which is something that will greatly increase your potential for tornadoes. And when we've got a greatly increased potential for tornadoes, that's when we need to start making decisions. And I turned to my coworkers and said, hey, we're going to need at least 6 people in here tonight. The bare bones staffing we normally have on an evening or a midnight shift, that's not going to work. We're going to need to do something a little bit different. And when the afternoon model runs started coming in, I'll use these as an example, the level of concern continued to grow because now we had more confidence that we were going to be seeing discrete storm development, supercell storm development, somewhere in the northern half of our forecast area. And at this point, we needed to start making some decisions and we needed to start taking some actions. The first action that we took was to collaborate with the Storm Prediction Center about 3 p.m. to increase the tornado probabilities across our area. To be honest with you, 5% is still not enough, but it was a step that we made with them to at least move the forecast in the right direction. The second thing that we did was create our contingency schedule to make sure that we would have enough people available in the office that night, people that can stay over on their shifts, people that can come in on their off time, to make sure that whatever happens, we've got the staffing available to cover it. The third thing that we did was put out an update on social media to increase the level of tornado threat. And we kind of sometimes stray from using the T word in our social media because we don't want to get people too alarmed. This was a day where we were okay with using it because we wanted people to know that the threat was going to occur and also that it might occur later in the evening and even into the overnight hours, a later time frame for severe weather than is typical. Before I went back into the office, I had some conversations with a couple of colleagues. This one with our Science and Operations Officer, Seth Benow, who is, as far as I know, currently on his way to Florida. But he, as Brian mentioned, Seth also brought up the Millbury EF4 tornado. And I mentioned that we had a run of the HER that was indicating basically that the southernmost cell, the supercell that we were expected to perhaps develop, was going to cut across the heart of our forecast area. This was something that obviously concerned the both of us significantly. Brian and I were sharing soundings with each other, doing our own mesoscale analysis, and he's looking at the LCLs and he's looking at the backed winds, and I note that whichever storm ends up, the tail end Charlie, basically at the southern end of the cluster of storms, was going to have a very potent mesoscale environment to work with. So I got into the office at 8, and here's what had been going on. The largest development of storms did not occur over Illinois, but as Kyle showed you, occurred over the central part of his forecast area in northern Indiana, and then continued to drift east-southeast into Ohio over the course of the next few hours. Here's a radar loop focused on our forecast area of everything that's going on. So you can see the storms he was dealing with, and you can see that the southern end of the storms, where we have the most significant supercells developed, really did cut across the heart of our forecast area. There were a few model runs, especially right around the time I walked into the office at 8, there were a few model runs suggesting it would be further north, and they didn't match with reality with what was even going on at the time in Indiana. So always, don't just take the models for what they're saying, look at how they are with what's going on the ground at the time. But we're going to focus on 5 storms. Just the 5 storms that created tornadoes in our forecast area. This one led to 4 tornadoes in our north, including the Salina tornado, and was also responsible for the ones that Kyle talked about, at least a few of them. There was this one supercell produced 1 tornado in Hardin County, the far northernmost county in our forecast area. This supercell, which created a total of 5 tornadoes in Miami County, for example. The biggest one, which created 6 tornadoes total, including the EF4 through Dayton, and the one following behind it that produced another 3 tornadoes. And what kind of wind environment did these have to work with? We did basically a wind analysis from our radar in Wilmington as kind of a proxy for the inflow into the storms at right around the time of the strongest tornadoes. And what we derived was that the 0 to 1 kilometer helicity was over 500, the 0 to 3 kilometer helicity over 700. These are extreme values that operate in a parameter space that is favorable not just for tornadoes, but for strong and violent tornadoes. So I'm going to set up what the office was looking like on this night when I walked in. Roles of radar operator, meaning you're the one issuing warnings, are typically assigned to people who either have no shift duties on the day or have completed their shift duties on the day. So I walk in, sit on that back wall. Since I was basically on my off time, I was given the role of primary radar operator, which is just the first step in, of course, deciding who's going to issue what warnings for what storms, because we don't have a specific plan for every weather event because they're all different, but we have a framework that we work in, expectations to build around so that operational tasks can be assigned and shifted based on the workload needs. So Brian, for example, who sat next to me, he jumped in as the secondary radar operator when I had to ask him to take a look at some other storms. Scott was working aviation, but quickly had to jump in and work on hydrology and flooding problems. Alan was doing the main part of the forecast, but also helped out with coordination and even doing some radar work himself. Kristen on this desk, she was helping out with social media and communications, but eventually also had to help out with radar and issuing warnings. Chris was working on social media and communications as well, in addition to our weather balloon launch that evening. When the midnight shift arrived at 10 p.m., they basically helped out wherever they could. We ended up with 8 people there during the most active part of the event. And total of 5 people issued tornado warnings during this event. If you ask someone what's it like in an office in this environment, the easy answer would be to say, oh, it's controlled chaos. But the truth is, you know what, it really wasn't chaos. It was busy, a little frantic at times perhaps, but it wasn't chaos because we know our roles, we know how to work with each other as a team, and we're able to get the job done because of that. Shortly after I walked in, the tornado watch for our forecast area was issued. And the first warnings were not too far behind. So when you think about warning decisions, there's kind of 3 keys that go into making a warning decision. Spotter reports, mesoscale environment, and what you're seeing on radar. Spotter reports, because this was going to be an event at night, we're going to take kind of probably a lower ranking on that scale just because we don't get a lot of them after dark. But the mesoscale environment was high end. And so that means the warnings were probably going to be issued fast and furiously as it ended up being. The first warning issued for our forecast area, I issued for northern Wayne County just before 9 p.m. So that's when the whole thing really started for us. And continued that warning as the storm marched across Wayne County and then eventually started to make its way into the state of Ohio. The first warning for Ohio issued at 9:36 p.m. in this event. And as that continued on, you'll notice that there are additional storms developing behind that first cluster in Wayne County, the storms that Brian mentioned in that one tweet he showed. I wonder what these are going to do. Well, we know what ends up happening out of that cluster of storms and what develops. And at the time, I've now got basically two supercells that are developing that I'm watching, and this is where the load shedding begins. And I say, the storms up north moving into Mercer County, I can't handle those. Brian, can you watch those for me? And he said yes. And so Brian issues the tornado warning for Mercer County, including Salina, at 9:55 p.m. We'll jump up to radar. It's a little bit messy because there's a lot going on here, a lot of other storms that are interacting with this one, the interference and whatever else. There's probably some of that going on here in Salina, but we'll flip over to velocities and see the strengthening circulation moving on its way to Salina. At this distance from our radar, it is kind of hard to judge exactly how strong this circulation is, but there are signs that it is pretty intense, including at this point in the loop right here. And as it moves over Salina, really just kind of north of downtown, we flip over and we can see on the correlation coefficient that we do in fact have a debris signature. This was the first tornadic debris signature that we had on this day. Of the, I think, 10 tornadoes of our 19 that we had in our forecast area that exhibited tornadic debris signatures. And as this tornado continued on a little past Salina, that debris signature showed us that this was, especially for a storm that far away from our radar, that this was not just a low-end tornado. And that started to let us know that this was going to be a more significant type of weather event. So at this point, I'm still watching these two storms further to the south, and the warning strategy changes a little bit because originally they were kind of clustered together, and I needed to make a decision that there's getting enough separation from each other that we're going to split them up into two different warnings. So the first storm, the one further north, I've got a warning out now across Preble County, Darke County, and then the second one I get a warning out across Preble County for that, to keep the two warnings separate, which does improve the quality of the warnings that are issued. The other decision I made was to increase the amount of time of the tornado warnings from our default of 30 minutes up to 45 minutes, to give those warnings a little bit more time to be out there. Right now, the focus is going to be on the northern of the two storms, as it's now warned heading into Miami County. So you can kind of see the supercell shape, even though it is embedded within other areas of heavy rain and whatever else. But if you flip over to velocities, you can see that you have a strengthening area of convergent rotation moving out of southeastern Darke County, almost due east into Miami County. And that circulation strengthens quickly as it approaches Laura. The correlation coefficient, debris signature, the one that got McCall choked up on air, at this point we're seeing the same thing, and of course our attention is that, okay, we've now got at least two confirmed tornadoes that have occurred from radar, so this is a more significant type of event. I'll show you one image from the terminal Doppler radar in Dayton near this tornado's peak intensity. Rotational velocity values on this about 65 knots, which is a pretty significant number. And at this point in the event, Scott turns to me and says, "Hey, Andy, would you consider issuing a particularly dangerous situation tornado warning?" Which no one has ever done in our office before, because that option's only existed for a few years. That's sort of one half rung below tornado emergency, but it's designed for storms where we believe we have a significant tornado, perhaps EF2 or higher, based on radar appearance and confirmation. I did not end up issuing it for this one, but as I look back at the strength of the rotation, and certainly the fact that we had debris being wafted by this tornado, I think it could have warranted one. I think it probably should have warranted one for this storm. It verified as an EF3, so it's kind of easy to say that now. That storm continued on, produced another few tornadoes before eventually dissipating, and our focus then turned to the storm to its south, which is now moving out of Preble County and into Montgomery County. And I issue the warning for this storm into Montgomery County at 10:31 p.m. It's at this point that the storm is just about to enter the Brookville area. In fact, the forward flank of the storm's already over Brookville, moving towards Trotwood. And it's another classic case of the convergent rotation turning into more pure rotation. At 10:44 p.m. for the first time, we see debris lofted from this tornado over Brookville. It's a very subtle signature, but it is there. And over the next couple of minutes, if you watch the left, that rotation that is strong but still looks like it's getting organized turns very intense very quickly. And if you watch on the right, the hook echo, you can see as it turns into a debris ball, indicating where the tornado is now located as it's just finished moving through Brookville. So at this point, with that and the strength of those velocity values and the fact that we do have a tornadic debris signature here, Scott's already given me the idea in my head, so it was an easy decision to issue the particularly dangerous situation tornado warning, which throws that little tag at the bottom. It says tornado damage threat considerable. And that's significant. Here's another radar loop, kind of a few images from just a couple minutes later, kind of the most classic appearance of this supercell with a classic hook echo going into the debris ball on reflectivity. Velocity values at this exact image, the strongest recorded from any tornado in our outbreak of 90 knots of rotational velocity. That's an average of 90 in and 90 out, basically, from this tornado. And classic appearances of debris on radar on both correlation coefficient and on differential reflectivity. So at this point, I make a message on NWS chat that says this appears to be a very damaging tornado, and those are strong words to use on chat. After I sent that message, I went quiet. I went silent on chat for probably almost an hour, which if you've ever been in NWS chat, if you're media or whatever, and I'm working radar in an event, if I go silent for an hour, that's not a good sign. Usually I'm pretty talkative on there. So begin to assess just how bad this is. We see debris at 7,000 feet above the ground. We see debris at 12,000 feet above the ground. We see debris at 19,000 feet above the ground. And at this point, I'm primary radar for this storm. So I'm scrolling and seeing these scans literally right the second they come in from the radar. And there's a split second where I know that debris is being lofted almost 4 miles into the air from this tornado, and I'm the only person on the planet who knows that. And I need to get that information out to people. 10:56 p.m., we start looking at making the biggest decision we can, which is a tornado emergency, which our regulations say can be issued in exceedingly rare situations. Severe threat to human life, catastrophic damage from a tornado is imminent or ongoing. So the little mental checklist you have to go through in your head, is it moving through a populated area? Yes, it is. Is it a confirmed tornado from radar? Absolutely, yes, it is. Do you have certainty that it is a strong, violent tornado? Well, we have debris to 2 miles, 3 miles, 4 miles high in the air. We have rotational velocity values that are pretty much off the charts for what we ever see in Ohio. And we have 1 or 2 spotter or amateur radio reports that have come in at this point of people that have seen the thing. So yes, we do have that confirmation. And the decision was made that a tornado emergency is going to be coming up for Montgomery County. At 10:56 p.m., I generate the text for that tornado emergency and realize, it wants me to make hand edits to the location where it's actually occurring, which is frustrating to me. But so I go in, I make the hand edits, and probably within, 30, 45 seconds, it's at 10:57, tornado emergency for Montgomery County is issued. Only the second time a tornado emergency has ever been issued from our office. And in fact, it was just about 10 years, almost to the day after I issued my first ever tornado warning. Tornado damage threat catastrophic is a weird thing to see at the bottom of one of our warnings. It's even stranger that I realized that I had to sign my name at the bottom of it. It was an easy decision to continue the tornado warning ahead, now moving into allowing it to continue into Greene County, continuing to use the tornado emergency wording for Montgomery County at this point. And from there, we can see that the debris has actually, at its peak, reached as high as maybe 25,000 feet in the air, which, according to research, correlates strongly to, at the very least, a high-end EF3, if not EF4 tornado. Of course, this would end up being rated an EF4 tornado. So at this point, this tornado's life cycle is about halfway through, and we see the circulation here, but it's also getting behind the outflow of the storm, and which means that the downdraft has essentially cut the tornado off from its source of warm and moist air. And the tornado's also kind of made a right turn at this point, and it's kind of moving now a little bit southeast rather than just east. So let's look at what's going on just ahead of it. Here's a tornado on the lowest level of our radar, but I'm going to scan up in our radar a little bit, and you can see that there's evidence of an additional development of circulation from the mesocyclone beginning to descend probably a mile, mile and a half to the east of where the tornado is actually located. And as I scan up a little higher to get an idea of where the actual parent mesocyclone is further aloft in the storm, I'll circle it here. So this is basically where the mesocyclone in the storm is located. And remember, the tornado's back here, and it's moving southeast. So what's going on? There's a couple things, of course, that are happening. Let's say a tornado develops underneath the center of a mesocyclone. But what happens then if the tornado gets kind of caught behind the storm? Now it's in an area where the cyclonic circulation of the mesocyclone has a southward component to the motion, and the tornado can begin to turn to the right as it gets further and further behind the mesocyclone, behind the outflow. But the mesocyclone continues on to the east. So here's what happens. And I'll plot the location of the tornado here. This is probably around the time it's crossing I-75, or maybe just after that. And out ahead of it, as that one dissipates, a new tornado develops. There is definitely a separation there, and we'll plot this one out as it continues, very quickly generating into an EF3 tornado in Beaver Creek in Greene County. And just to finish plotting this out, and then compare it to what we surveyed, and end up with clear evidence that there was a break in the paths from these two. 20-mile track on the EF4, and about a 10 or 11-mile track on the EF3, mainly in Greene County. Here's what it looked like at its peak in the Beaver Creek area. A well-defined debris ball, a well-defined circulation with velocity values somewhere on the order of 70, maybe 80 knots of rotational velocity. And of course, debris evident on radar from this one as well. Put them all together, once again, another tornadic debris signature. So if you watch this radar loop focused on the center of the storm and watch, looking at the debris ball as a proxy for where the tornado is, you can almost watch it as it rotates around the parent mesocyclone of the storm. As the first one forms, and then it's going to dissipate, and the second one forms right there. It's really a fascinating loop if you look at it basically from the perspective of the storm, not from the perspective of the ground geography. It's an interesting way to look at thunderstorms. But that wasn't the last supercell we had to deal with on the day. And we had, Brian was still keeping himself busy with the storms up in Auglaize, now Hardin County. We had either Kristen or Al were issuing warnings on the storms in central Ohio, and there were a lot of them. But I've also got this other supercell that's now developed behind the Beaver Creek storm, moving right through there, and this other supercell's developed behind it and is moving almost on a parallel track right behind it. So yes, a lot more to deal with here. And this storm first produces a tornado over Phillipsburg, and it's a weak one, just an EF0, but it was just the start. As the storm continued onward, as the hook echo passed between Englewood and Vandalia, a new circulation developed. At this point, Kristen's responsible for this storm, and she makes a great call to also issue a particularly dangerous situation tornado warning with velocity values that supported it and a tornadic debris signature that supported it, verifying as a high-end EF2 tornado. Crossing I-75 2.5 miles north of where the first tornado crossed I-75 at. You'll notice this one also gets behind the outflow from the storm. And is it also going to try and cycle like the one in Beaver Creek did? It was very close. You can see that there is signs of a developing circulation in the Huber Heights area. But here's why it didn't happen. Here's from terminal Doppler radar in Dayton, the circulation located right here, and the outflow of the storm quickly just blows the whole thing away. One thing looking back at these storms that was very obvious is that the second supercell of these two supercells moving one right after the other had much stronger, probably much colder outflow, which quickly made it less likely to continue to produce strong tornadoes going out into the future. Although this storm did go on to produce one more. So like I mentioned, in central Ohio, things are busy. And we've got people putting out warnings along the US 23 corridor. One of them, at least, came very, very close to producing a tornado. In fact, I might say that it probably did, but didn't produce enough damage for us to confirm anything. This is in Licking County, just west of the terminal Doppler radar site for the Columbus airport. And here's a circulation that's very close to the radar. How close is that and how strong is it? That's probably about a 40-knot circulation, 120 feet above the ground. That's low enough that you're basically sampling a tornado here, but if there's not enough damage, I think there may have been a Bradford pear knocked over by this, and you can't confirm anything off of one Bradford pear getting knocked down, but it's very possible that there was a tornado in central Ohio from this. So now I'm going to jump down back into Greene County. We're continuing to issue warnings on the two big supercells that we've been watching for a while now. Here's a radar image at 11:45 p.m. You see where Jamestown is. Here's a radar image at 12:21 a.m. I'm going to flip back and forth between the two. It's imagine you're in Jamestown, you're like, oh man, I just dealt with one of these 45 minutes ago, and I got another one bearing down on me again. Well, they both produced tornadoes, and we're going to track them out. Here's the circulation from the first tornado. Put the little tornado icon on it, and we'll just plot out this circulation as it crossed through Greene County, doink, 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 going off into Fayette County, basically along a line like that. Second supercell comes through, the tornado has developed right about here, and I'm going to follow this one out the same way, follow the circulation on its kind of similar path, also ending just across the line into Fayette County, Ohio. Put both of the lines there, and then we'll compare it to the results we got from the damage survey. The answer is yes, we had two separate tornadoes on converging paths with each other. I have no idea how you figure out which damage is caused by which tornado near the end of that path, but Brandon did a great job of putting that together for us as best he absolutely could. The lead supercell of the two continued to produce additional tornadoes. Circleville in Pickaway County with a tornadic debris signature. Tarleton also in Pickaway County. And then in Laurelville in Hocking County, also with a tornadic debris signature. And actually the Laurelville tornadic debris signature was actually one of the higher tornadic debris signatures of the day, and it verified as an EF2, so that certainly makes some sense. The second supercell, as it was exiting Hocking County, moved through a very rural area, but had a circulation of about 50 knots of rotational velocity, and that's pretty intense. You would expect to find some damage there, but it's a very rural area. No known storm damage occurred, and we were in communication with emergency management and everything. Was there a tornado there? That strength of circulation would indicate that it's certainly possible that there was, but it's nothing that we were able to confirm with no damage known to us. 37 warnings later, the last storms are exiting Hocking County. At this point, John is issuing warnings on them, cleaning up the mess that we've all created. Over 5 hours after we were done, all tornado warnings for our forecast area have expired. Of course, we were just getting started on the amount of work that we had to deal with. So there's a map of all the warnings that we issued. And then at this point, before the event was actually even done, I had started work on creating preliminary track polygons based on where the circulations were at their strongest and where we think tornadoes may have occurred. These blue polygons are essentially something that we create on a routine basis after tornadoes if we think there may need to be a survey, and we share them with emergency management to say, hey, this is where we're going to focus on, this is where you should focus on also, and we'll maybe meet up tomorrow. But there was so much interest in where we were going to be going, where we were concerned about, that we made these public from this event, and I saw them all over the place, from the TV to on social media, in newspaper articles, wherever. These preliminary swaths that are normally sort of an in-house thing kind of got a lot of play, but they helped us to plan out our attack for the surveys, for the first day of surveys, which began at 8 a.m. I got off work at 3 a.m. the night before, and I was back in just 5 hours later to help this process out. The first survey, Seth and Ryan went to Montgomery County to try to survey the worst of the damage. They couldn't get into where the worst of the damage occurred because it had just happened and there was just so much commotion going on. Julie and Matt went out to Greene County to look at the Beaver Creek tornado. Todd went all by himself up to Mercer and Auglaize counties to survey what would end up being something like 20 miles of tornado tracks up in those two counties, a long way from home in Wilmington. Kristen and Jim went out to look at some of the last tornadoes from the event in Pickaway and Hocking counties. And I went up in the air with the Ohio State Highway Patrol to do aerial support for the worst damaged areas in Montgomery and Greene counties. As this is all going on, there's a severe thunderstorm watch issued about 1 o'clock this afternoon, and we left 4 people at the office to try and deal with an event that did include, it wasn't a significant event, but we did have warnings. We did have storms in the area of Mercer County at the very least, that's bad. You don't want storms on an area that's just had significant tornado damage. But I mean, to say every single one of us was kept busy is an understatement. So the Ohio State Highway Patrol comes and lands their helicopter in a field just to the north of our office. I took this picture. You can see some of the office people, some of my coworkers waving to me on the way out. But took the flight. Here's the path that we flew to try and cover these damaged swaths and figure out what exactly happened. And of course, this flight was very instrumental in helping to confirm the EF4 across Trotwood and Dayton, the EF3 across Beaver Creek into Greene County, the EF0 in Phillipsburg, and the points that I plotted. It's just a complete mess. I mean, there were literally hundreds and hundreds of points that I saw from the air, and I took probably close to 1,500 pictures on that day, of which at least 1,200 of them actually turned out. So, well, it has helped us to find the first damage that occurred. The very start, well before it was in EF4, a few trees down to the west of Brookville. But as it moved into Brookville, creating, of course, EF2 and then eventually EF3 damage, especially as it moved into the Trotwood area. And being able to see all of this from the air, you can see, the colors on the walls in people's homes, the roofs of multifamily buildings thrown over a wooded area and across the street completely. Within the areas of damage, you'll see areas of more significant damage, swaths perhaps caused by the mesovortices or the suction vortices inside the tornado. This tornado was 20 miles long. Probably at least 11 miles of it had at least some sporadic EF3 level damage. The worst of the damage, which eventually was confirmed as EF4, occurred near the banks of the Stillwater River in the Shiloh area. The first thing you'll notice here is 1,200 feet of trees completely mowed down. They completely obliterated, basically, from this tornado. But it's the multifamily homes, the apartment or condos or whatever these were, right on the banks of the river that sustained some of the heaviest damage from this tornado, where you have a significant combination of roof loss and wall loss. In some cases, that third level was almost completely gone. The tree damage exhibited was some trees were bent, some trees were nubbed, some trees were snapped off, and you had some that were even debarked, which is something that doesn't occur except in the most violent of tornadoes. So looking at the enhanced Fujita scale, the category for apartments, condominiums, and townhouses, most top-story walls collapse, get you an estimated wind speed of 158 miles per hour. Almost total destruction of the top 2 stories would give you 180 miles an hour. We're probably somewhere in between those 2 categories, and you come up with, if you go between the two, about 170 miles per hour for a rating at the low end of the EF4 scale. That's very significant. The Beaver Creek tornado that developed shortly after the EF4 dissipated, if very possible that actually it dissipated and this one developed almost right at the exact same time, or even that they were both on the ground together for a very, very brief period of time. This one created EF3 damage, mainly just at the start of its track, the first couple miles into Greene County, with significant amount of EF1 and EF2 damage that then continued out over its 10 or 11 mile track, ending on the north end of maybe 4 or 5, 6 miles north of Xenia. The last known damage from this tornado just to an outbuilding at a farm, but it was this was the end of the 30-mile swath, basically, of these 2 tornadoes combined, cut across Montgomery and Greene counties. We then went up to the other swath of damage we were looking at from the second supercell. The Phillipsburg EF0 is interesting mainly in the sense that it's the only tornado that our office, as far as I know, has ever confirmed solely via aerial survey. We never even sent a ground survey to this. To be honest, the grain bin in the field is kind of more what we're used to dealing with than the massive swaths of damage we saw elsewhere. The EF2 that moved across northeastern Montgomery County, one of the more interesting things we saw from that is you had a swath of trees heavily damaged east of a mile or 2 east of I-75. The tree damage here is probably enough that it would on its own get a high EF1, if not into the EF2 rating, and it is that close to a mobile home park. We're talking, what, 500 feet, if not less than that? It obviously doesn't take an EF4 to rip apart a trailer park, and so if you had the tornado of this magnitude just 500 feet to the south, we could have been looking at a much more significant situation, much more horrible situation from this tornado. So at the end of the first day of surveys, we confirmed a total of 8 tornadoes, which is a lot, but we knew that the work was just beginning. And so we came right back in the next morning, planned out day 2. I went with Jeremy to Miami County to investigate what would be the West Milton EF3 as well as an EF0 in Troy. Julie went out to Dart County to investigate the earliest 2 tornadoes that we had from this event in our forecast area. Seth went to look at some light damage in Hardin, where he found a tornado, Franklin and Licking counties, where he did not. And the last survey, the Double Trouble survey in eastern Greene County that Brandon and Alan went out and take a look at. So my survey was focused mainly on Miami County and a little bit in Dart County. This is the path we drove through Ludlow Falls, West Milton, Laura area, all the damage points that I plotted from that one, and eventually turning that into the eventual swath, the final polygon that we got for this EF3 tornado. So yes, you might ask, okay, well, how do you determine the width of a tornado? The truth is everything's made up and the points don't matter. That's not actually the truth. The truth actually is that what you want to try to do is focus on the areas where the damage is most concentrated, most clearly associated with the circulation. In some places you may have damage that's even wider than that, whether it's from the edge of the circulation, enhanced inflow, or your flank downdraft or whatever. But this one I ended up going with 3/4 of a mile for the width of this tornado, but it's kind of uncertain. To some extent you are just kind of using your best judgment to figure that kind of thing out. The damage from this tornado got its EF3 rating due to a combination of wall and roof loss to, I think it was 3 or 4 fairly well-built homes, mainly near and just northwest of West Milton. Some things like this, and some of the debris, of course, sent a very long ways out from the tornado across some of the fields. This was a kind of a rural area, but it was not an unpopulated area. There were homes on every street that were impacted from this tornado. And we're just about done with the survey, and we're driving one of the last few roads just to kind of pick out some damage points, and I see this home. Now, this is a modular home, so it's not going to rank real high on the EF scale or anything like that, but it was almost completely demolished, as you can see here. And I said, no, we got to stop. We got to see what's going on here. There were a lot of people outside, people who I wanted to talk to and see, okay, did you experience this? It turns out the person who lived in this home with his wife was there and was able to talk to me. And he sheltered from the storm in this interior bathroom, where that's pretty much the only walls left standing. In fact, he said the only reason that the door didn't open during the storm and lead to a worse situation was because there was a couch that got wedged up against that interior room and kept it kind of closed off. And he and his wife escaped with no injuries outside of some scratches or whatever. And if there's ever an advertisement for the power of the get to the smallest interior room you can find, this is a very good one for that. But the person also told me something else. He told me we had very little warning. And I'm thinking, what? He wasn't mad, but he was wrong. They did have warning. They had 18 minutes of warning from the warning that I issued at this exact location. And so I was concerned. I didn't really know how to respond, because how do you can't just tell them, no, you're wrong when you're talking to somebody who's just lost his home and his possessions are across the field. I don't know how far away, but it concerns me because it gets into the whole process of how people receive warnings. And I don't want to get too far into the whole siren thing. McCall had a great answer on that, but the question is, if this is an older method of notifying people about tornado warnings, and this quote from a Dayton Daily News article, I think, just encapsulates the problem, which is that people still consider sirens tantamount to tornado warning, siren equal tornado warning, when the reality is tornado warnings are getting out there in much more reliable, modern ways, and we need people to understand that and to take action based on those ways as well, if not primarily. I don't know how we get to that point. The social scientists are working on it, and it's a frustrating thing for us. Warnings with significant lead time are not acted upon. But it's just something that we're all going to have to deal with somehow. At the end of the second day of surveys, we ended up with another 9 tornadoes confirmed, which brought our total to 17. And I apologize for anyone in the media who was trying to keep up with the tornado count, because it was literally just changing. Like you get your story out and it'd already be wrong. So I apologize for that. But typically we don't have to confirm 17 tornadoes across 2 days. That wasn't the end. On the 3rd day, we planned out a couple more surveys. We had 3 people go back to the heaviest hit areas of Montgomery County to examine those areas again. Seth went out to eastern Miami County, where he was able to confirm another tornado, giving us a total of 18. And this was also the day when the EF4 upgrade was made to the Montgomery County tornado. And that still wasn't it, because the next day, Todd finished looking through all of his data from his survey in Auglaize and Mercer counties or whatever, found evidence of another tornado, which brought our total to 19. And then our neighboring offices in Charleston and Pittsburgh, they had 2 tornadoes as well, which brought the state total for Ohio to 21 tornadoes from the event. And we do believe that's still not it. Because survey number 12, a few days later, Seth went out to look at some tornado, some damage in Greene County near Cedarville, which was not conclusive enough to determine if a tornado occurred. And several weeks after the fact, we received a damage report in northern Wayne County. There wasn't much else to look at. Most everything had been cleaned up, so there's no way we can make a confirmation this many weeks after the fact. But there was damage there. It could have been an additional tornado. We really don't know for sure. But with 21, we made no additional confirmations, wrapping it up with a total of the 21 tornadoes of the first EF4 in Ohio. Since that Millbury tornado that has been mentioned a few times today, the first EF4 in our forecast area since the Pioneer, Kentucky EF4 in northern Kentucky during the March 2012 outbreak. And it was the first EF3 either in the state of Ohio or our forecast area since the Cedarville EF3 in Greene County in 2014. I want to take a quick second to mention our social media performance from this event. I'm going to start with a tweet that we sent out on May 24th that said, above normal temperatures and isolated thunderstorms, have a great Memorial Day weekend. Okay, let's move on from that one. You probably see the botted tweets that go out from our office indicating tornado warning, in this case tornado emergency, but we were also sending tweets manually, writing out in all caps, yes, we're screaming at you again just like we used to, that things are bad. And we hope that people understand that if we're doing that, that it is a serious, serious situation. Those tweets are much more, as we found, much more actionable than just the automated botted tweets. They had 3 times as many views, 6 times as many retweets. I think the message was getting out. And I want to mention also, if we look at span of 3 days on our Twitter platform, how many views do our tweets get over the average span of 3 days? It's about 150,000. How many views did we get the second greatest span of 3 days that we ever had? It was actually just a month after the outbreak, and we had over 800,000 views on our tweets. But the number 1 span was the 3 days including and after the outbreak, where we had almost 4 million views on the tweets that we sent out from our office. I think that's an illustration of the power of our voice and the Weather Service voice on social media. Perhaps more importantly, I want to mention our warning performance. We issued 37 tornado warnings during the event, issued by 5 different people. And out of those tornado warnings, of course, we end up with 19 tornadoes. Total of 100 miles or so of tornado track, and a total on the ground time of about 3 hours. And every mile of every minute of every tornado had a warning out in advance with a probability of detection of 100%. On the initial touchdown of 15 minutes. The EF3 damage from the 4 tornadoes that produced damage of that level all had at least 12 minutes of lead time. And the Dayton EF4 damage, 34 minutes of lead time on the initial warning with 8 minutes of lead time after the tornado emergency was issued. This is, I think, a resounding success for the National Weather Service warning program. Wow. Stripping this away to warnings I issued. 17 of them, 13 tornadoes in the warnings that I issued, and I'll tell you what, that's a lot to deal with, not just during the event, but after the event. I want to show you the hours that I worked, starting 2 days before the event, where I did have 2 long shifts with thunderstorms, to the day of the outbreak, where I basically worked 2 shifts, came back in at 8 a.m., worked long, basically morning, well into the night, and then switched to midnight shifts just a couple days after the outbreak, over 80 hours in 1 week. And when you're at work after this kind of thing, dealing with a tornado outbreak is basically all you're doing. It overwhelmed everything going on in my life, like in an all-encompassing, almost uncontrollable way. When you're at work, you're dealing with the tracks and the website and media requests. And I hope nobody was looking at the forecast I was putting out at this time, because they probably weren't very good. But at home, when I'm at home, I'm tweeting about it. I'm talking to friends about it. These are text messages I sent to some friends. This was after the first day of surveys that this is kind of what's consuming my life at this point was just tornadoes. You realize the enormity of that. You've spent your whole career training for an event where you see the worst case simulation type of thing you don't expect to actually have to do in real life, but it's there, and you've been trained to do it, but now you have to do it, and you have to do it quickly, and you have all that pressure on your shoulders. A few days later, I was able to run the dishwasher for the first time in a week and a half. I mean, it's a step in the right direction, so excellent, I guess. But we actually had a few weeks after the event, we had a stress management counselor come into the office. This was, like I said, it was a tough time. We had more severe weather, we had more flooding, we had people with heightened emotions, patience was running thin. It was good to have a chance to talk about taking this event from the past, turning it into the past, and moving on into the present and getting back on. And I asked the counselor, well, okay, how do you shut that off then? And she said, well, what do you do when you go back to work? And I said, well, we have a mission. We have a mission statement. We go in, we have tasks to write, we have a forecast to put out. We just get back to work the way we always get back to work, because that's what we know how to do. And she says, no, stop. That's good, you got to do all that, but you got to find another way to move forward. Find something else that you can focus on. Find something else so that you can move ahead into the future. Like I said, we brought her in on Tuesday, June 11th, and had plans to bring her in another day on June 20th. It was canceled due to flash flooding. Life in the weather service, is it not? So on June 11th, we wrapped the event up. We sent out a statement. We thanked our spotters, emergency management officials, everyone that was involved, and that was it. The tracks were all done, the website was all done, and I was done. I shut it off for quite a while. It wasn't until putting together a poster for the National Weather Association conference in September that I kind of looked at it a little bit, but to be honest, the poster was just kind of thrown together from things I tweeted, so I didn't have to go too in-depth into anything. But it was in December when we had an integrated warning team workshop in the Dayton area with our media and emergency management people, our partners. And Seth did a short presentation and led a discussion on the outbreak. And he showed pictures from it, and he showed radar images from it, and you very quickly jump back into, oh, yeah, I remember all of that. And it jumps back into your mind very, very quickly. But it was actually the thing that stuck out of me the most this day was I had a conversation with Kirsty Zontini from WHIO. She pulled me aside and she asked me, what was it like when you were issuing the tornado warnings that night? And at first I'm like, I've never really kind of answered that question, have I? I maybe told a few close friends right after the event about it, but I've never really gone back and shared that story of what it's like. And so the answer is that it starts out like normal. I'm issuing warnings, I'm well trained on it, I'm fast, I can draw stuff on WarnGen quick as just about anybody, I can assimilate all the radar data in the world. And then the turning point for me was when the particularly dangerous situation warning as the storm was moving past Brookville was issued, because after that point for me everything changed. And all of a sudden, all of my normal level of detachment and emotional unavailability started to dissipate, started to fade away, and I realized, no, this is real. This is much more significant than anything you've done before. And it is something that takes a toll. Issuing the tornado emergency then was very hard. It wasn't a hard decision, it was actually a rather easy decision, but it's hard to realize that you've got to make that decision when that many people are at risk, and that many lives are at risk, and that you're the one that holds the key, hopefully, to increasing that level of alert to the highest level, to get them to take shelter, and hope that they make it through. So this is something that it takes its toll, and you'll move on. You'll move on to your sunny days, you'll move on to your spotter training classes, you'll move on to the next severe weather event eventually, but a lot of weather service meteorologists never go through a night like that one, where you basically hit for the cycle, issuing a tornado warning, a particularly dangerous situation tornado warning, a tornado emergency, all in the same night, and you verify them with EF0, EF1, EF2, EF3, and EF4 tornadoes. It ends up as the kind of, really it's a career-defining moment that you can move past to some extent, but you're never, ever going to forget. And well, I guess there's still one thing left, but you know what? You know what? I hope to hell I never have to deal with it. any way involved in that event. Emergency management, media, my weather service partners, thank you, and thank everyone for being here today.
Thank you, Andy, for that awesome presentation. Now is our lunch break until 2 o'clock. And if you are a speaker, please come meet me around the stage. And there's plenty of drinks and water.